Hello, Mrs. Allison here. Today we're going to look at even and odd degree and the leading coefficient of a polynomial, whether it's positive or negative, that would be your a value, in transformation form. So first we're going to look at even versus odd degree. So if we remember, we have our parent functions y equals x. There's the graph of that. We have y equals x cubed. There's our graph of that. And then also another function that we haven't really talked about but is still a polynomial would be y equals x to the fifth. And there's the graph of that. So if you remember from last week, y equals x is our linear function. Okay, notice with the line, the degree would be 1. X to the first power is a line. Okay, here's our cubic function that we studied last week. It has a degree of 3. And then this last function here is called a quintic function. It has a degree of 5. Notice all of these graphs, the end behavior goes right and up, down, left. Okay, right and up, left and down. Okay, let's take a look at some more parent functions we've studied. This would be x squared. That's a parent function we looked at last week. X to the fourth is another parent function. And then one we haven't studied but can also include as a parent function of a polynomial is x to the sixth power. Okay, remember our x squared is called a quadratic. Okay, it has a degree of 2. This is our quartic. Think of quarter, 4. Has a degree of 4. And then this one is called a sextic. Has a degree of 6. And notice the end behavior of all three of these functions. As we go right, it goes up. As we go left, it goes up. All three of them go up, whether we go right or left. Okay, so what can we conclude? Our odd degree functions, so the 1, 3, and 5, the arrows are opposite for the end behavior. Our even degree functions, so our squared, fourth, and sixth, the arrows go in the same direction. Okay, so even versus odd degree. You're looking at that exponent there. Now let's look at positive versus a negative a value or leading coefficient, that number out front of our parent function. Okay, so let's take a look at our odd functions. So remember, this is our line, this is our cubic, and our quintic. Okay, notice here, they all go up as we go right. Okay, here are the same functions, but notice they have a negative in front there. Okay, so these ones all go up as we go right. These ones that have the negative in front all go down as we go right. Okay, let's look at our even functions. That would be our quadratic, quartic, and our sextic. Okay, they all go up in both directions. Notice these graphs with the negative in front. Okay, so these ones all go up as we go right. These ones with the negative in front all go down as we go right. So what can we conclude? Well, if they have a positive a value, so a positive number out front, the arrows will go up as you go right. Whether it's an even function or odd function, the arrows go up. Okay, when we have a negative a value in front, so a negative in front, think about our reflection of our transformation, our arrows go down as we go right. Whether it's an even or odd function, it goes down as we go right. Okay, and that's because we're reflecting the graph down in terms of transformations. Okay, so now let's look at a transformed function. So we've only looked at parent functions. We're going to go ahead and look at some examples of transformed functions. Okay, now we're not actually going to use transformations to graph it, but we're going to kind of come up with some, the degree and the leading coefficient, so some ways to kind of sketch the graph without having actual points. Okay, so the first thing we want to look at is the degree here. Remember, that's your exponent. So this would have an exponent of 3, so my degree would be 3. And because 3 is an odd number, that means that my function, the degree, would be odd. Okay, this polynomial is an odd degree function. Okay, then we want to look at the number out front to determine whether it's positive or negative. So the number out front is a 2, which is greater than 0. Okay, 2 is a positive number. So therefore, my function is positive. So what can we conclude? Since it's an odd degree function, my arrows are going to go in opposite directions. Okay, since a is positive, then that means we will go up as we go right. So because they have to go in opposite directions here, as we go left, we're going to go down. As we go right, we're going to go up. Okay, and here was what the graph would look like. Okay, let's look at another example here. So here, first, if we find our degree, the exponent is a 4. So therefore, the degree is 4, which makes this a quartic function. Because 4 is an even number, that means the degree of my polynomial is even. Okay, then we're going to look at whether it's positive or negative. So if we look out front, we see that there's a negative there. So that tells me that it's negative, which means it's reflected down. Okay, so what can we conclude? Because it's an even function, my arrows go in the same direction. And both of those arrows are going to go down because of that negative out front. So your end behavior, as we go down left, it goes down. As we go right, it goes down. Okay, and here would be a sketch of that graph. Okay, here's another transformed function here. Notice my degree, the exponent is 7, so therefore the degree is 7. Since 7 is an odd number, that means that my function will have an odd degree polynomial. Okay, then we look at positive versus negative. We don't really care about the 1/4 in front. Remember, that's going to be vertically compressing my graph. We just care that there's a negative sign out front. So that tells me my graph is going to be negative or reflected in terms of transformations. Okay, so what can we conclude? My odd function will have opposite direction arrows because 7 is odd. And then because that graph is negative, that means my arrow is going to go down as we go right. As we move across the graph, it's going down. Okay, so as we go left, it goes up. As we go right, it goes down. Okay, so here's what that graph would look like. Very similar to the cubic function, okay, the x cubed. Just a few different points here. It's more flat there. Okay, last one here. Hopefully by now we are getting kind of the hang of what we're looking for. So the degree would be 8. That is your exponent. Okay, so in this case, because 8 is is an even number, that means that my degree of my polynomial would be even. Then we look out front. There's no number out front, so you could put a 1 out there if you wanted to. But regardless, because there's not a negative, that means my function is positive. Okay, so because of that, we can conclude that they are going to go in the same direction, and my arrows will go in the same direction, and they both will go up because it's positive. So as we go left, it goes up. As we go right, it goes up. And here's what the sketch of that graph would look like. Okay, so hopefully at this point now we are good with determining the degree, whether it's even or odd, and then also determining whether my graph is positive, negative. So now you can go ahead and complete the Schoology assignment that practices this information. Have a great day.